Hi everybody. So this is going to be the first lesson for Unit 8. If you have the Unit 8 packet that I handed out the last time we were in school together, then you can just write directly in that packet. If you don't have the packet, I'm posting a PDF of it on Google Classroom, so you can either use Kami or some other software to write directly on there if you want, or if you have a printer, you can print it. And if you don't have a printer and you don't feel comfortable writing on your computer, you could also just write it on loose leaf and sketch out the graphs as best you can. As long as whatever you're doing is helping you learn, it doesn't really matter which way you do it. And, we'll deal with what we can. So for right now, we're going to be doing the equation of a line for this first lesson. Later on in here, we are going to be doing proofs, but those proofs aren't going to be like the ones that we did before. So most people say that these proofs are actually a lot easier. They don't have nearly as much writing, but hopefully we'll be in school by the time we have to do those. So for the opening exercise for the first lesson, we're going to figure out slope. So there's a couple different ways you could do slope. The way that I like best is doing this formula. So that formula is to find slope, which is m. We always write a lowercase m for slope. You're going to do the difference in the y values of your 2 points over the difference in the x values for your 2 points. And it doesn't matter which one you choose as x1, y1, and x2, y2, as long as you're consistent with it. So in case if you don't remember what that means, every time we have a point, we have an x and y value. X is in the first spot, y is in the second spot. And then when you've got 2 points, so like the point A that we've got here, we've got x1, y1 as our 2 spots here. So 6 is going to be x1 and 4 is going to be y1. And then for our second point, it's x2, y2. So 9 is x2 and 5 is y2. You can have this whole thing swapped if you want to, and have 6, 4 be x2, y2, and have 9, 5 be x1, y1, but you can't mix and match. So what I mean by that is you can't have x1 and then y2 together. That doesn't work. And you also can't have 2 x's together and 2 y's together for your points, because the first one has to be an x value and the second one has to be a y value. So if you're good with that, you could just plug in those numbers. So y2 minus y1 is going to be y2, which is 5, minus y1, which is 4, over the difference in the x values. So that's x2 minus x1. And when you subtract the 2 numbers on the top, you get 1. Subtract the 2 numbers on the bottom, you get 3. So our slope is 1/3. And slope is also, if you've learned it as rise over run, then the 1 is your rise, and your 3 is the run. So that means you're going up 1 and over 3 on your graph. Now, some people don't like to do it the algebra way, and they would rather graph it. You can graph it, especially with these because they're smaller numbers, but this way is always one that will work. So if you've got a graph like we've got here, you could plot the 2 points and then do your slope this way. Rise 1, 1, 2, 3, so we've got 1 over 3. We're also going to try and figure out what the y-intercept is going to be for the line between these 2 points. Okay? If we have a line that's got those 2 points and we wanted to extend it, we're going to try and see where it crosses the y-axis. So since we're extending it, that means we have to have the same slope. So since we had to go up 1 over 3 to get from A to B, we're going to go up 1 over 3 again and keep doing that in that direction. But once we've run out of room over here, we have to do the same thing but in the opposite direction. So instead of going up 1 right 3, we're going to go down 1, left 3, and go right here. Then we're going to go down 1, left 3 again. And you're going to keep doing that over and over again until you run out of room over here. And once you've got that, let's see, let me add my last few points in. You can connect them all and put arrows on the end. And it says up here to call this line K. So I'm going to call it line K. Okay, so we're going to figure out the y-intercept. That means we're going to find out whatever the number is for where it crosses the y-axis, which is going to be right here, and that is where y equals 2. So we're going to say y equals 2. That is our y-intercept. You could also say that it's the point 0, 2, or just 2 works for now too. Okay. The next part, it says we're going to write the equation of the line. So everything that you've done up to this point has been the slope-intercept form. So that's y equals mx plus b. It's called the slope-intercept form because the two things that you're plugging in is going to be the slope and the y-intercept. The slope is m and the y-intercept is b. What we figured out already is that the slope is 1/3. Okay, so we know that m is 1/3. And then the y-intercept, we just figured that out too, right here, is going to be 2. So b equals 2. And you're going to plug that into this formula. And remember, you're not going to put anything in for x and y. Most of the time when we do stuff like this, we're plugging in numbers for x and y. But in this case, we're going to leave x and y exactly how they are. And just plug in for m, which is 1/3. And we're going to plug in for b, which is 2. So this equation that we've got right here, if you were to put that in y equals in your calculator and go to the graph, it will look like this. And if you go to the table, you'll see that these points up here, 6, 4, and 9, 5, those 2 points are going to be on the table for this equation, for that line. Now, that's not the only way you can figure out what the equation of the line is. Sometimes they don't give you all of this information. If they give you the slope and they don't give you the y-intercept, but they give you something else, maybe they give you a point, then that's going to be something that we can actually do more math with than we could before. So that brings us to this equation. In the past, you guys have used the slope-intercept form, y equals mx plus b, where you plug in the slope and you plug in the intercept. But you could also figure out the same thing using the point-slope formula. So point-slope, the point is going to be this. So x1, y1. And slope is still m. So this is basically a way of figuring out what the formula for the line is without doing this work that we did up here. Okay, for this we had to graph it and figure out all the pieces this way. And sometimes, especially when we don't have nice numbers like 2, we can use this to figure out what our equation is going to be. So first, I'm going to prove to you that this equation works. So this is the new equation that we're going to be using for a while. I'm going to show you that it works. So let's start with this. This is a random line that's already in y equals mx plus b form, right? If this is y equals mx plus b, then 3 is m, which is the slope. So that's our slope. And that's going to be this part of our equation. And now we need a point. So we're going to come up with a point. Most of the time for these, they'll give you the slope and a point though. So this is just a proof for this. So we could pick any point that lies on this line. There's a couple ways you can do that. The way I'm going to do it is I'm going to say any x value. So I'm going to say 4. So I just made up 4, but the rest of this is going to be consistent for the rest of them. So if x equals 4, I can plug that into this. So y equals 3 times x, which is 4, minus 2. That means y equals 12 minus 2, y equals 10. So that means that the point 4, 10 is on the line y equals 3x minus 2. You could always do that if you wanted to find a point on a line, but you could also do this. You go to y equals on your calculator and go to the table. After you type in what the equation is, you're going to get all of these numbers. So if you go to y equals, type in 3x minus 2, then go to the table. These are all of the points that are on the line. Okay, all of the whole number points. So if you notice, 410, that is one of the points on the line. You could choose any of these points, even the ones with negative numbers, and it'll still work. So I'm going to use 410. If you want, you can go ahead and try another number and see if that works too, but they'll all end up having the same answer at the end. So we're going to use the point 410 as x1, y1. So that means x1 equals 4, y1 equals 10. And that's our point for our point slope formula. And our slope is going to be 3 because we figured that out earlier. And we're going to plug that into this equation right here. So our equation is y minus y1 equals m times x minus x1. So the x and the y that don't have 1s on them, you're just going to leave those alone. And we're going to plug in for the rest. So y minus y1 is going to be y minus 10. M is 3. And then x1 is 4. So plugging into that formula, we've got this as an equation of the line, which is going to be the same as this. But let's prove that that is actually the same thing. So take this equation, and we're going to do a little bit of algebra with it. So 3 times x is 3x. 3 times negative 4 is negative 12. All of this stays the same. Now we want to get y by itself, so let's add 10 over. And now we've just taken the equation that we came up with before, using a point that was on the line and the same slope, and we've come up with this equation of the line. And that should look pretty familiar because that's the exact same thing that we started with. 3x minus 2, 3x minus 2. So since those are the same thing, and they'll be the same for any of these points that you plug in. Okay, anything on the left, you plug in for x, and whatever is matching with it on the right, you plug in for y. It will always end up being the same exact final answer down here. So that's going to be enough proof for us to be using this equation as another way of doing y equals mx plus b. Except we're going to use this way whenever we're given the slope and a point. Okay? And we'll be using this one up here if we're given the slope and the y-intercept. Okay, so we're going to choose which formula we're using based on the information that they gave us. So let's try that again for another example. We're going to use the formula from up here. So we've got y minus y1 equals m times x minus x1. And we're going to plug in the numbers that they gave us. we know that we're going to be using the point slope formula, which is this one that I just wrote, because it gave us a point and it gave us the slope. So when they give us point and slope, we're going to use the point slope formula. And we're going to take that and we're going to turn it into the slope intercept formula, which is y equals mx plus b. So let's take what we know. This is the point, so that is going to be x1, y1. So that means x1 is the one that's in the x spot, so that's 2. y1 is going to be the number that's in the y spot, so that's -5. And then the slope is 1/2. So we're going to do m equals 1/2. And we're going to take those three numbers and we're going to plug them into the formula. So y minus y1, so that's going to be minus a -5. And whenever you subtract a negative number, it's the same thing as adding a positive. So I'm going to change that to plus right there. And then the slope is 1/2, and then x minus y1, which is 2, or x1, which is 2. And then we're going to do just like we did up here. We're going to distribute and then get y by itself and see what y equals mx plus b is going to look like. And then we've got 1/2 times -2, which is going to be -1. And then this is what our final answer is going to be. And if you want to check your work, you can go in your calculator, go into y equals and type this in, and look at your table after that, and you're going to see that this point is going to be on your table, and the slope is going to be 1/2. So if you were to graph this out, it would be rise 1 over 2. Okay, so let's try that again. Okay, if you think you've got it, you can pause the video and do it on your own first. But if you want to see me do it again, then we've got this. If you think that you've got it though, and you don't want to watch me go through it, I still want you to watch it just because I want you to hear what I'm saying in case if I say something that's going to make it easier for you. So if you want to watch it at 1.5 speed or double speed just to make it move a little faster, you definitely can do that. So we're going to do the same thing. We are given a point and we're given the slope, so we're going to use the point slope formula. This gives us x1 and y1, which is -3 and 13. And this tells us that the slope is -2. So we're going to plug into our formula. And we're just going to take all of those numbers and put them in and make our final answer be y equals mx plus b, except we're going to replace the m and the b with the numbers that make sense with this. Okay, again, we've got minus a negative here. Minus a -3 is the same thing as +3. And we're going to distribute the -2. And then add the 13 over. And this is what we're going to get for our answer. So you should have y equals -2x plus 7. Okay, so this isn't the only way we can use this formula. It also helps to determine the equation when the graph is given and they only tell you the y-intercept. So for this, so let's see. Oh, sorry. It says when the y-intercept is not a whole number value. So if you look really closely at this, see how the y-intercept isn't quite at 1? So it's not really the nicest thing ever on here. If it was at 1, then we could say, okay, b equals 1, and then we can count what the slope is and just plug into y equals mx plus b. If they don't give us a nice number for the y-intercept, then we could always use the formula that we just were using, and we can figure it out that way. So this is what the process is going to be. Step 1, we're going to pick a point. Pick a point. And then we're going to also find the slope. And then we can do the point slope formula. And then after that, we're going to do the same exact process that we've been doing. Once you plug it into this, then you can come up with your own y equals mx plus b. And finding out what the y-intercept is going to be whatever b is in your y equals mx plus b. So let's do this process. We're going to pick a point on here. I'm going to choose the point 1, 1 because that's going to be very easy for us to use in this because 1s are nice. So I'm going to do 1, 1. You could choose some other ones. Just make sure that whatever you choose, you're choosing something that's on like a cross part here. You don't want to choose something that's like how this one is. Okay, you want it to be something where you know exactly what the number is. So I'm picking the point 1, 1. And we also want to figure out the slope. So the slope for this, we're going to find another point that is on one of those little cross spots. So I'm going to choose this one. You could also choose this one, that works too. But if we were to choose the first ones that I went with, we're going to go up 1 and over 1, 2, 3, 4. So that means that the slope is going to be 1 over 4. You could do that just by counting on there like I did, or you can do the difference in the y's over the difference in the x's like we did in the opening exercise. Either way, you're going to end up with the slope being 1 over 4. And then for the point slope formula, we're going to plug in basically what we just found. So m is 1 over 4. x1 and y1 are going to come from the point that we used. So for me, I chose it to be 1, 1, which makes it pretty straightforward for us to just use 1s. But if you wanted to do something like this, then that's the point -3, 0. And this would be x1, this would be y1. And no matter what point you end up using, you're still going to end up getting the same answer at the end. So if you want to try it a different way with different numbers and see if you get the same thing as me, then that's definitely good. So we're going to plug into the formula, which is y minus y1 equals m times x minus x1. Put all of those numbers in. And I'm leaving mine as fractions because you want to keep your slope as a fraction. But if you want to change the last part into a decimal, you definitely can. So your final answer is going to be y equals, I'm going to rewrite it down here, y equals 1/4 x plus 3 over 4, or you could say y equals 1/4 x plus 0.75 if you wanted to reduce into decimals. But it's always a good idea to keep the slope as a fraction because that represents the 1/4 for rise over run over here. So we're going to just double check that this is going to work. So if you were to take the numbers that you see on here, the x values that you see, that are going to be whole number answers, that's what we're going to go with. So I'm going to put this in another color. So the x values that are going to end up on nice points, as I'm calling them, are going to be this, which is the point 1, 1, 1, and the x value is 1, so I'm just going to do the x values for now. Another one that is a nice one is this point, and that is right here, so that is going to be 5. And if we were to go in the other direction, this one right here is -3. And another one that is a nice one is this point, which is -7. So I'm going to use those x values as a way of, verifying that this is correct. So I have -7 from smallest to biggest, -3, 1, and 5. So if we took -7 and we plugged it into this formula, so y equals 1/4 times -7 plus 0.75, and you put that in your calculator, the answer that you're going to get is going to be -1. And if you did the same thing, except now you did -3 instead of -7, your answer is going to be 0. If you did the same thing, but now you replaced your x value with 1, y is going to equal 1. And then if you replace this with 5 and you plug that all in, you are going to get it's equal to. Now, why do these numbers matter? These are going to be points on the line. So to double check if this formula over here works, we're going to see if the point -7, -1 is a point on this line. So let's look. -7, -1, yep, that's this one. All right, let's check the next one. -3, 0, yep, that's this. We already talked about that one before. 1, 1, yep, that's this one. And then this other one, 5, 2, which you could write as 5, 2, like this, is this point right here. So yes, this equation that we came up with over here is definitely correct because we know that all of these things are going to match up with the algebra that we did down here. So what I want you guys to do is I want you to try the next page on your own, okay? If you're stuck on anything, I've kind of written out the important parts over here. You're going to plug into this formula, the same one we've been doing for the entire lesson. You're going to plug in for these 3 pieces for the first 3 problems on here. And then the next 2, it's giving you 2 points. So you're going to use the slope formula to find the slope. And then you could pick whichever point you want to be your x1, y1, and use that to plug into this formula up here. And I'm going to take the answers to this and I'm going to post it on Google Classroom shortly after I post this video. So that way you could watch the video, you can try it on your own, then go back and see if you got the right answers. And that's going to be kind of like what we would do in class, where I would say, okay, you guys work on it and I'll walk around and help. That's going to be close to that, except I'm going to give you the answers right away. And if you have any questions on any of that, make sure you let me know and I'll try and answer the questions as best I can. Now, beyond this page that you're doing on your own, I want you to do the homework page, and you're going to turn that in on Google Classroom. I'm going to make an assignment for it. and you're going to, take a picture of it or scan it, and you can put it in on Google Classroom that way. If you don't have a way of doing that and you'd rather type your answers and share it with me as a Google Doc, that works too. It's a little bit more complicated when you've got graphs involved. So if you do have the paper, that way is probably best. But this is going to be how I always check homework. So I'm not looking for complete accuracy. I want to see that you're trying. I want to see that you've got it done. So if you're really struggling with something, you can ask your classmates to help you, but don't just copy it just to copy it, because it doesn't actually count for that much. Okay, I'd rather see that you guys are trying it on your own first.